Hello out there. Happy Wednesday. It's the 6th of May today. Hope you're all having a good week. Happy hump day. And here we are again talking about NCC changes for the 2019 code and the residential version, so volume 2. We've done this webinar several times now, but I know there's still plenty of you out there who aren't sure what's going on with the code changes, so let's crack on. Oh, look, it's Max. So this webinar is eligible for a CPD point, Green Star CPD point, Sustainable Development CPD point if you didn't already know. So interact in the chat, let us know you're here and say goodbye at the end, and then we can issue you a certificate of attendance if you contact us at info@suho.com.au. So what is changing? So basically 2016 code is now expired and we are now in full swing of NCC 2019. This was delayed by 12 months, so obviously it's 2020 now, not 2019. This change was delayed by 12 months from the 1st of May last year to the 1st of May this year to allow the industry to get their heads around the changes. And now we are, with the exception of Western Australia, who have opted to have another 12-month waiting period, and also a couple of the other states, Northern Territory, Queensland and New South Wales have got their own regulations they go by, but all the other states and territories are going by NCC 2019. So under the section 3.12 and in the volume 2 of the building code, there are 3 different ways you can obtain a compliance with the energy efficiency requirements. That hasn't changed. So NCC 2016 and NCC 2019, the 3 options are still there. It's just that the parameters around them have slightly changed. So deemed to satisfy, well, that one hasn't changed. Nothing's really changed there. The rules are more or less the same. However, the glazing calculator under the DTS requirements is usually too stringent. Excuse me, Max. Is usually too stringent to use. So we usually go for a couple of the performance methods instead of the DTS method because it's usually more flexible and cheaper to get compliance using the performance calculations. So 6 stars is the most common type of energy efficiency rating that Australia knows about. It's the most widely spoken about, and you just have to, we run your design through our NatHers software, and it needs to achieve 6 out of 10 stars in order to comply. That's the minimum requirement under the star rating system now across Australia. There are some various concessions in different states, but basically 6 stars is the minimum. The only difference now, excuse me, using my chair as a jungle gym. The only difference now is that there are now heating and cooling load limits in different parts of Australia. So not all areas in Australia, not all NatHers climate zones have got these limits, but here in South Australia we have these limits. So if you get to 6 stars in South Australia, you still need to achieve heating and cooling load limits, which may bump you up to 6.1 or 6.2 stars depending on how out of whack your heating and cooling load is. The purpose of that is to bring the 2 in line and make sure that your house is comfortable in summer and in winter, because previously the heating and cooling load limits were simply added together and plotted within a star band graph, a star band table. But now you have to achieve certain heating load limit and cooling load limit in order to reach compliance, so that it brings those two elements more in line with each other, so they're not out of balance and you don't end up with a really hot or really cold house even though you've got energy compliance. Verification method, or V2622, or reference building compliance, reference building method, is the most common method that we've used over the past few years at Suho. It's not very well understood, but we are experts in it. you're comparing the house that you want to build to a DTS compliant reference building. So up until the 1st of May 2020, this method was used quite widely by those who understood it because it was always cheaper than going for a 6-star assessment. The flexibility that it afforded was quite good. The change under 2019 have been quite significant to this assessment method. So what that means is the reference building, which previously under 2016 we could do quite a lot with to alter the performance of it, even though it was a DTS compliant building, there was quite a lot we could do to alter the performance of that building and make the building that you want to build more energy efficient than the DTS compliant version. Those flexibilities have now been taken away. The reference building is now a prescribed construction. We can't change window sizes. There is a very set recipe as to how that reference building has to be constructed, which means that compliance under this method is now a lot harder and more expensive for the build cost than using the 6-star rating method. So the thing with the verification method is that a lot of people aren't aware that using that verification method meant that there were 2 and 3 and 4-star houses that were still being built because it was so flexible. We had clients come to us because we were experts in that method and we understood it, and it allowed a lot of architecturally designed homes to be built when they weren't able to achieve 6 stars. We could still get them through energy compliance using verification. So under the level of star rating, although when people talk about energy compliance, they think that star ratings are the only way to get through the code, up until 1st of May, that wasn't entirely correct. So the verification method is still in the building code. It's still usable for certain designs, very standard sort of volume home builder type designs, but it's very much more strict now. So here in Adelaide, we've got 2 NatHERS climate zones. We've got climate zone 16, which is the Adelaide Plains, and we've got 59, which is sort of Mount Lofty Hills area. Some of you may or may not be aware that there are 8 building code climate zones, 1 through to 8, 1 being the hottest, 8 being the coldest. There are 69 sub-climate zones under the NatHERS, National House Energy Rating Scheme system. So each of those 8 climate zones is broken down further into smaller NatHERS climate zones for the purposes of the energy rating. So climate zone 16 is the Adelaide Plains. In order to achieve compliance, the heating load must be under 67 megajoules per square metre per year, and the cooling load must be under 52 megajoules per square metre per year. So these will obviously change. You can see in the colder climate zone of 59 up in the hills, the heating load has got a lot more tolerance because it's obviously very cold there. There needs to be a higher tolerance for higher heating loads. This is the front cover of a booklet which sets out all of those heating and cooling loads. They also differ depending on floor type. So concrete slab on ground and elevated timber floor have got different heating and cooling load limits. So this is a basic zoning orientation guide that we give to our clients, and we understand that not every block, not every house is going to be able to adapt to these basic passive design principles. But still, the principles exist and they're there for a reason. The software operates under these sorts of principles. There are also certain things about the software that we know work and things that we know that don't work. So we can point these out to you at design phase. So typically you want your living areas to the north because the sun rises in the east and sets in the west, and it spends most of its time in the northern part of the sky down here in the southern hemisphere. So that's when you're going to get most of your solar gains. The sun is going to penetrate into your home on the northern side of the building for the most time throughout the day. The east is typically sleeping zones. You get the morning sun, and then as the sun passes over and goes down in the evenings, on those really hot summer days, you don't still have the sun beating through your bedroom window, and your bedroom will be very hot when you go to bed. Typically on the west car parks, because those are unconditioned zones, and we don't really, doesn't matter if they, well, it matters a little bit, I suppose, but that is going to be the most uncomfortable spot in your house on a hot summer's day. So to have zones where you're not actually going to be living on the west is the ideal layout. On the south, bathrooms and other utility zones, storage areas, because that's going to be the coldest side of the house. And it's, if you're not going to be, we try to keep the areas where you're going to be habitating the least on the most uncomfortable areas of the house. So west and south are going to be the most uncomfortable depending on time of year, generally speaking, and also depending on shading factors and things like that for summer. Some little tips about using the software and what works and what doesn't. And again, we understand that this is not always going to be ideal for your design. However, these are things that we come to understand about the software. So separating habitable and non-habitable areas with a door works quite well for keeping heating and cooling loads under control. Living areas to the north, bathrooms, laundries to the south, bedrooms to the east. Eave depth and shading devices. So shading, especially to the north and the west, is very important. The depth of that shading, obviously the sun changes position throughout the year. In the summer, the sun is higher in the sky, and in the winter it's lower. So the sun is going to be penetrating further into your home in the winter because it's lower in the sky, and that's what you want. You want to be able to design your shading factors, your shading devices, your pergolas, your eaves around the angles of the sun. I know it's not always that easy, but we do model shading factors in our software. We model eaves, we model neighbouring buildings, we model pergolas and fresco areas, and all of those things impact the passive solar heat gain. Ideally, the software doesn't like any designs over 180 square metres. So anything architecturally designed, anything that's slightly larger, the software will generally, it penalises you if you go over that threshold purely because of the additional floor area and volume. Minimising external wall area is another tip. So we've had designs, for example, that have internal courtyards, which look very, very nice, but because you've got all this additional wall area, it just increases the amount of surface area where heat and cold can transfer in and out of the building. So it destabilises the internal conditions, and your heating and cooling loads will suffer, which will knock you down a couple of star bands. So this is what a multi-storey dwelling looks like when it's modelled in First Rate 5. So we take your floor plan and it gets transferred in 2D into the software. So we need things like wall construction, floor type, orientation, all these sorts of things to model the building. The grey area is a garage. The blue areas are other daytime areas. I think this might have been a gym or something. Storage areas, outdoor laundries or something like that. Next level up is the living area. So the green area is the main living zone. And all of these different colours have got different occupancies assigned to them. So the garage is obviously not occupied. These areas here are assumed to be occupied from, I think, 7 in the morning until 10 o'clock at night, or 11 o'clock at night. The main living area is assumed to also be occupied between 7 in the morning and 11 o'clock at night. However, this also takes into account additional heat gains from cooking. Bedrooms, the pink is a bedroom that's assumed to be occupied between 7 p.m. and 7 a.m. or something like that. Off the top of my head, I can't exactly remember what the occupancy patterns are, but the software has all sorts of assumptions about what behaviour the occupants of the house are going to have when they're going to be putting on a jumper, when they're going to be opening windows, all sorts of things. These yellow stripes around the building are the windows. This has got double glazing, this house. These yellow the yellow indicates double glazing, the blue indicates single glazing, and all of these dotted lines and these solid lines here indicate neighbouring buildings. So I was mentioning before, we model all of the shading factors. These blue lines here are eaves and pergolas and alfresco areas. This is the third level, bedrooms. The greeny blue areas are wet areas. So again, zoning, shading, eaves, windows, orientation. So this house, when we first modelled it, the base rating was 2.7 stars. So obviously it had a long way to go to get to 6 stars. All of these upgrades were applied. We had to, we included a very high specification of double glazing. We used a very high level of insulation on the upper level walls, polystyrene product, as well as bulk insulation in the walls. So the total R value would have been up around R4 or so. Roof blankets, additional ceiling insulation. We had to reduce some windows because in residential designs, windows are everything. The size and the specification of the windows matter a great deal to the outcome of the energy assessment, because basically a window is a giant hole in your fabric, and it's never going to perform as well thermally as a wall. So once you stick a window in a wall, you're reducing the performance of the overall wall, and you need to make up for that with a better frame and better glazing, better treatments on the windows, etc., particularly with very large designs. Additional insulation to retaining walls even. And we had to also include internal doorways to control airflow inside a house and zone it off a little bit. And even once we did all of that, we could only get it to 4.9 stars. So this is kind of what happens when a builder or an architect or a designer goes through the design process with a client without thinking about the energy efficiency in the design and potentially the orientation early on. The assessment comes across our desk, and all of a sudden, under verification, this house, under the performance solution with the reference building, this building would have passed. But under the new regulations, having to get to 6 stars, it's obviously going to be challenging. So if you're designing something that's architectural, very large, it's a good idea to get someone to run their eyes over it before you finalise your design and before your client gets their heart set on a layout. Because if it comes across our desk and we can't get it to 6 stars, there is a very real risk that we won't be able to get energy compliance, and you may have to review the design. So going back over some general design advice, just around what we know works in the software. Living areas should, if possible, face the northern aspect. The windows should have optimal eave design, and we can help you with shadow diagrams and things like that to help you work out what the sun is doing at different times of the day and different times of the year to optimize your eave depths. Provide a thermally effective building envelope. So 6 stars out of 10 stars is the minimum you need to get energy compliance. And in order to achieve that for most designs, you need to install quite effective insulation. Glazing to floor area ratio should be no more than 25% or so. So the square meterage of the windows compared to the square meterage of the floors. The windows should be no more than about 25% of the total floor area. If you use concrete for your walls and suspended floors, insulating those concrete areas is a good idea. Uninsulated thermal mass works well in certain, if it's designed in certain areas of the house with certain sun angles in mind. But if you insulate it, it will be a more stable product for your dwelling, because it can be quite it's slow to react to external environments, the heavy concrete walls and block walls, and insulating it actually controls the thermal properties of it better than just leaving it to its own devices. Lower ceilings and smaller rooms is obviously going to reduce your heating and cooling loads. Again, that's not probably going to be an ideal design piece of advice, because smaller rooms and lower ceilings generally isn't what people want. However, it does work better in the software. Less corridors. Corridors and hallways are actually a huge vortex. Like the heating and cooling loads in those areas are usually very high. So if you can reduce the number of corridors you have, then you'll have a better chance of getting your heating and cooling loads down a little bit, and avoiding double height voids, because they obviously add volume to your design. In order to help clients predict their star rating long before the energy assessment ever comes across an energy assessor's desk, we have an internal software development team who, for the past year or more, 18 months, have been working on a piece of software called Hubble. This is a piece of software that's exclusive to Suho, and it is designed to help you predict your star rating using some really basic parameters. So wall construction, roof color here on this page, whether or not you've got suspended floor insulation, ceiling insulation, etc., etc. Windows, approximate window sizes, window specification, insulation levels, with some really basic parameters and an idea of which direction the house is facing, based on the thousands and thousands and thousands of assessments that we've done at Suho over the past 15 or 16 years. We're using an AI algorithm to help you predict your star rating. So we're quite proud of this software. It's still under development, but it's ready to be used, and what it does is it stops that disappointment. Like this design back here, it stops it, or tries to help prevent this situation where a design actually isn't going to be buildable potentially because of the energy assessment, and that's a heartbreaking situation to be in for a client. So this software is very user-friendly. It was designed to be very user-friendly and simple, but also as accurate as possible. And we've got this software within about a 0.3 of a star accuracy for single-story dwellings. So it's very positive. So that's all I've got today for the residential changes, the changes to the Residential Building Code. This afternoon we have Designing the Home of the Future, and then tomorrow and Friday we've got some stuff on air tightness and some more stuff on the code changes. So thank you for joining me today, and I'll see if there are any questions. Timo, you're back. Timo, we use First Rate 5. And if First Rate 5, if we do also use Accurate if First Rate 5 isn't going to cut the mustard, so to speak. But mostly we use First Rate 5. Hello, Angie. Welcome back. Max, yes, it was his first time live. He's famous now. He's now sleeping on the floor like a good boy instead of being naughty and climbing all over the chair. Is there a 2019 heating and cooling load limits table available from the ABCB? Yes, there is. So if I go back to this page here, this little document here, it's a small booklet which goes through all of the different NatHERS climate zones and tells you whether or not they have heating and cooling load limits based on the NatHERS climate zone and based on the floor type. So that can be, oh, there we go, there's an answer here for you anyway. So you can download this booklet from that link that's been provided in the chat. There we go. Yes, so you can learn more about Hubble next Friday, May 15th at 11 a.m. if you would like to know more about how the software works. Oops. There we go. That's my final slide for today. So thanks for joining me, and we'll see you next time at one of our other webinars. Bye, everyone.